Okay, we are back. Now, like I said, we've already brought in this and we've kind of figured out how to do this. We don't need any of this information anymore. You can save it if you want. So, like I said, I had already done that step previously where I'd run through that and had taken all those data, had flattened them out and normalized them, and then mosaiced them together, and then I had extracted the successional gradient kind of area that we had. Okay? So, this last file here, we are going to check our histogram function again. Oh, no, that's it. We can write it in here. It's all good. No, I don't want to overwrite what I did. Control Z. Okay. Let's do a histogram function. So we want to do hist las at data Z. Yeah, cool. So that one's already normalized. It's already been cleaned up. That's what we need. So we can get rid of this step because we don't need any double check on that. So let's pull back to our root vignette and get the next set of code of things that we need. Okay. So now what we want to do is we want to clip out some stuff. So we want to bring in the shape file that pulls out just the forest. This file does not seem to exist because, Jeff, you forgot to delete the dot. There it is. So there's our shape file. I think we can actually probably plot this so you can see it. Yeah, there you go. That's cool. I don't know why it makes 3 squares, but it should be that shape, so that looks great. Let's just kind of roll with that. So now, what we want to do with this step's a little funky. It gets kind of a GIS step, and these code probably looks totally crazy to you. So what this is going to use a transform function to basically take my shape file that I have here, which is, as you can see, this one's in decimal degrees, whereas, my LAS file, that one is in UTM, for Universal Transverse Mercator, so it's in meters versus decimal degrees. What this is going to do is this is going to take the CRS, which is Coordinate Reference System, using the shapefile package, and it's going to make the Blandy successional shapefile the same coordinate reference system as my LAS file. That way, they are best friends, and they can live together forever. Now, remember the filter POI, which POI was point of interest? We're going to use the clip ROI, or region of interest, for this. So we're going to take our LAS file, and we're going to basically clip out just the shape area where that Blandy successional gradient is, and make a LAS clip directory, or a thing, and this looks pretty good. Now, what I want to do is I want to plot this guy and see what it looks like. So I'm using Lidar Plot function here, and I'm going to plot the last clip. I want to color it using the Veridis package that I mentioned earlier in the setup, using a palette called Magma, which is going to make it like purple and white and everything. And the background of that's going to be white. I don't want any axis, but I do want the legend. So let's plot this and see what it looks like. And now the Lidar plot gives you this interactive plot, actually, where you can kind of scroll in and you can see we actually do have some errant points that we should have filtered out. That can happen a lot with Lidar, right? Like there's probably not really a 58-meter tree here. Maybe it hit some smoke or some debris or a bird even, like who even knows? So what we want to do then is we want to go back and we want to clip out that bad point because we don't want that. Now, earlier we did it from the last file, but like we can do it here too. Like it's not that big of a deal. It's the last clip, and we want to filter POI, last clip, and we want to just copy the code because we already wrote it. It doesn't really matter, but it's really just a put it in the frame. Less than Z, or you want it greater than 0 and less than 60. Let's clip it at 40. And let's run our plot again. Cool, now you can see it's topped out at 40. And that gives us better definition on that. Because anything more than a 40-meter tree in Northern Virginia is kind of nuts, honestly. This is not smart fancy. But it's kind of cool. It's interesting. You can see like we lost some of the points that kind of in here. So if we were, for this, where we were kind of interested in looking at the canopy in particular, but if we wanted to create a DTM or a digital terrain model that looks at the ground underneath this, we might want to use a different approach. But here we wanted to kind of isolate and look at the canopy. Get a good look at that. Now, the last part in that image was doing the transect. And the transect was kind of cool, and so it's going to give you a little bit more extra code that you can look at as well. So, for this, I just picked basically 2 points. And from drawing a straight line in Google Earth there and approximating the points, like, okay, this gives me a straight cut through that part, because if you remember, it looked like this, right? Like we want to get from the low to the high, but we're working in that diagonal. So I already kind of pulled out some points. You can do that in Google Earth. Run my points. Remember, they have to be in the same coordinate space as the file, which is in that UTM zone 17 jam. And so we're going to use the clip transect function here. And how this works is it's like I want to clip the last data set, which has already been normalized. And I want to go from point 1 to point 2. I want to do a width of 4 meters and xz equals true. I actually don't know what that xz equals true means. So one cool thing you can do in R is with a function, you can put a little question mark in front of it. Hit that, and it's going to bring up the help file on here and tell you what that is. XZ. If true, the point cloud is reoriented to fit on XZ coordinates. Okay, cool. So it's going to make like a nice little 2D thing. And like, cool. We'll run it with it, like we have it, and then we'll run it without and see what that does. Okay, so now we've clipped our transect. Now to plot this, instead of using the plot function in here, we're going to use the GG plot. GG comes from a book called The Grammar of Graphics. And so what we're going to do is we're going to give it our data set, which is that last transect. Remember at data, because that's how you get to the data in a las function. And then our aesthetic is going to be x equals x and y equals z. And we're going to color it by z. And the other information in here that's it's a GG plot is we're telling it to do points. The geometry is going to be in points. We want them to be 0.75. I don't actually know what the units are on this, but you can play with it. If you go bigger, they get bigger. We want the coordinates to be equal, meaning that for every the x and the z will be kind of oriented the same. Theme minimal is just a graphic thing that tells it like I don't want it to be fancy. We'll run it with both and then see how it looks like. And then we want to color the points. The scale color gradients based on the number is going to again use that magma value. And we told it to color it by z, so it's going to color it should scale it by that value. Let's see what it looks like. And it should come up in here and be really small. Yeah, there it is. So there we go. So now we have created our transect. Let's run it without coordinate equal and we'll see how crazy it gets. Again, that comment, I put a comment here. It's just going to skip that line and run the rest of it. Now let's see what wildness happens. Oh, it looks terrible. So now what you've done is it's kind of just it's just kind of scrunched it up to kind of fit the region of the plot rather than the region of the data. So just kind of something to be aware of. So actually, let's take that out and let's do this as false. And I just want to see what happens. And graph it again. Beats me. I'm sure it might actually do something different, but I don't really know what it did with that. So that's how you recreate, kind of the data that we had in that paper, and get the transect, and then get the, kind of point clouds up to, something you can graph that. And so in the next one, we're going to play with forest gap R a little bit.